From the breath we take to the weather we experience, the atmosphere is central to life on Earth. It is an invisible shield, a life-giving blanket, and a dynamic system constantly shaping our world. In this video, we'll explore 4 key aspects of the atmosphere: its layers, its composition, the weather and climate patterns it generates, and the human impact that now threatens its balance. The atmosphere is the thin layer of gases that surrounds our planet, acting as both a shield and a cradle for life. Composed mainly of nitrogen and oxygen, it protects us from harmful solar radiation, regulates temperature, and enables weather patterns. From the gentle breeze to powerful storms, the atmosphere shapes our environment and connects every living thing. Its delicate balance is essential not only for our survival, but for the thriving diversity of life on Earth. The atmosphere has 5 main layers, each with distinct functions. Troposphere, 0 to 10 to 12 kilometers. This is Earth's living zone. All weather, clouds, rain, typhoons, happens here. The air is densest, and it contains most of the oxygen we breathe. In the Philippines, typhoons like Haiyan, Yolanda, form in the troposphere, bringing both destruction and essential rainfall. Airplanes also fly here, though in the upper levels. Stratosphere, 1250 kilometers. Above the troposphere lies the stratosphere, home to the ozone layer, which shields us from harmful ultraviolet radiation. Without it, life on land would not survive. This layer is stable and calm, making it ideal for long-haul commercial flights. Mesosphere, 50 to 85 kilometers. Here, temperatures drop drastically, and meteors entering Earth's atmosphere burn up, appearing as shooting stars. Without this protective layer, countless meteors would crash into Earth daily. Thermosphere, 85 to 600 kilometers. Temperatures rise sharply here, reaching thousands of degrees. The ionosphere, part of this layer, reflects radio waves, enabling long-distance communication. It is also where the auroras, the northern and southern lights, light up the sky, caused by solar particles colliding with gases. Exosphere, 600 to 10,000 kilometers. The outermost layer, gradually fading into outer space. Satellites orbit here, transmitting signals for GPS, weather forecasting, and communication. The air we breathe may seem simple, but it is a finely balanced mixture. 78% nitrogen, N2, essential for plant growth and the nitrogen cycle. 21% oxygen, O2, vital for human and animal survival. 0.93% argon, R, inert, non-reactive gas. 0.04% carbon dioxide, CO2. Though tiny, it is critical for photosynthesis and climate regulation. This composition supports life and moderates Earth's temperature. Air has key properties. It is invisible, has mass, exerts pressure, and can be compressed. Examples: oxygen fuels our breathing and fires. Nitrogen helps enrich soil through fertilizers. Carbon dioxide, though naturally low, is rising due to human activity, intensifying the greenhouse effect and climate change. Atmospheric processes create weather and long-term climate patterns. Weather refers to short-term conditions like rain, heat, storms, and wind. Climate describes long-term averages, such as the Philippines' tropical monsoon climate. Examples: in the Philippines, weather alternates between the dry season, amihan, and the wet season, habagat. Typhoons frequently strike, shaped by warm Pacific waters. In India, monsoon winds bring heavy summer rains, vital for farming, but also cause devastating floods. In the United States, Tornado Alley experiences powerful tornadoes when cold and warm air masses collide. In polar regions, climate is cold and dry, while in equatorial regions, it is hot and wet year-round. These patterns are influenced by latitude, altitude, ocean currents, and atmospheric circulation. Understanding them is essential for disaster preparedness, agriculture, and everyday life. Human activities are dramatically altering the atmosphere. Air pollution. Smoke from vehicles and factories creates smog, seen in Metro Manila, Beijing, and Los Angeles. It reduces air quality and harms health. greenhouse gas emissions, carbon dioxide and methane from burning fossil fuels trap heat, causing global warming. In the Philippines, this contributes to stronger typhoons, flooding, and rising sea levels. Ozone depletion. CFCs once thinned the ozone layer, increasing UV radiation. Global cooperation through the Montreal Protocol has helped the ozone recover, showing that solutions are possible. Deforestation. Large-scale cutting of forests, such as in the Amazon or Sierra Madre in the Philippines, reduces carbon absorption, worsening climate change. Introduced in 1920, the Corona's climate classification remains a cornerstone of Philippine meteorology. By dividing the country into 4 types based on rainfall, it captures the true essence of our climate. Dr. Coronas was a Filipino meteorologist working with the Philippine Weather Bureau, the predecessor of today's PAGASA. In 1920, he introduced the Corona's climate classification, a system designed specifically for the Philippines. Unlike global systems like Köppen and Geiger that focus on temperature and vegetation, Corona's emphasized rainfall distribution. Because in our tropical country, temperature is fairly uniform, but rainfall varies dramatically. Corona's identified 4 climate types in the Philippines, each shaped by rainfall patterns and the influence of monsoons. Type 1 has 2 pronounced seasons, a dry season from November to April and a wet season from May to October. This type is found on the western side of Luzon, Palawan, and parts of Negros, with examples including Metro Manila, the Ilocos region, and Zambales. Type 2 has no dry season and experiences very heavy rainfall throughout the year, especially from November to January. It is found on the eastern side facing the Pacific, such as the Bicol region, Samar, Leyte, and eastern Mindanao. Type 3 has seasons that are not very pronounced, with relatively dry months from November to April and wet months during the rest of the year. This type occurs in valleys and leeward sides like the western Cagayan Valley, parts of central Luzon, and Bukidnon. Finally, Type 4 has rainfall that is more or less evenly distributed throughout the year, without a marked dry or wet season. This climate type is found in scattered areas including Batanes, parts of Palawan, Mindoro, and the Davao region, making them favorable for year-round agriculture. When we look at the Philippines through the Corona's lens, a clear pattern emerges. The western areas experience 2 distinct seasons, shaped by the southwest monsoon or habagat. The eastern seaboard, directly facing the Pacific trade winds, receives rainfall throughout the year, making it one of the wettest regions in the country. Valleys and inland provinces enjoy moderate wet and dry periods, while scattered islands like Batanes and the Davao region experience rainfall that is evenly distributed year-round. This classification shows us how geography and monsoons interact to create diverse living conditions across the archipelago. The Corona's climate classification remains highly relevant today for 3 important reasons. First, agriculture. Farmers depend on seasonal rainfall to decide when to plant and harvest their crops. Second, disaster preparedness. Identifying areas prone to heavy rains and typhoons allows communities to strengthen their resilience and readiness. Third, development planning. Infrastructure, water supply systems, and housing projects must all be designed with climate patterns in mind. For example, knowing that Eastern Visayas has no dry season helps planners design flood-resilient structures and drainage systems. In contrast, the Ilocos region relies on its long dry months for tobacco curing and mango production, showcasing how climate directly influences local economies and livelihoods. The Corona's climate classification, introduced over a century ago, continues to guide us in understanding how rainfall shapes our daily lives. From farming to disaster planning and development, it reminds us that our climate is both a challenge and an opportunity, and that adapting wisely ensures a safer, more sustainable future for all Filipinos.